Hi, welcome to my video on the explanation of extraneous root. Solve a system of equations y equals x plus 2 and y equals the root of x plus 4. Notice that this is a linear equation, degrees 1, and this is a square root equation or a radical equation because it has a root. And we're going to solve this graphically. And before we do, we'll take each equation and graph each equation separately. So y equals, and because I have a linear equation, y equals mx plus b, and notice that m is 1 and the b is 2. So that's the slope and the y-intercept, m and b, and the slope is 1, but it's really, you could have it 1 over 1 as a fraction because it's rise over run. So when I graph this equation, I graph the y-intercept first, which is 2. So the y-intercept is 2, and the slope is up 1, right 1, up 1, right 1, or it could be down 1, left 2, or now down 1, left 1, down 1, left 1, and I have this line that passes through all of these points, and that's the line that represents this equation of y equals x plus 2. Now we have the equation y equals the root of x plus 4, and this is a square root equation or radical equation, and the basic graph of the radical equation, or I should say the basic table of values, the equation is y equals root x, and the table of values is 0, 1, 4, 9. That's the ones I use. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, the square root of 9 is 3, and we have if we use the mapping rule, then the mapping rule maps, and this is an x plus 4, so it has to be x minus 4 comma y. So the table of values is x minus 4y. So that means you're going to take 0 and plug it in and take 4 off as a minus 4. Put 1 in, and I get 1 minus 4 is negative 3. Put a 4 in. 4 minus 4 is 0. Put a 9 in, or sub in. 9 minus 4 is 5. So the x values are subtracting 4, but the y values are not changing. So 0, 1, 2, 3. So when I graph this table of values, x is negative 4, which is here. Y is 0. X is negative 3, y is 1. X is negative 3, y is 1. X is 0, y is 2. X is 0, y is 2. X is 5, y is 3. X is 5, y is 3. So now I draw the graph that represents the square root equation or the radical equation, and there's the graph. And notice that the graph has moved 4 left from the basic, and the basic graph is the one that passes through these set of 4 points. And notice that we're solving graphically, so it has the solution or the answer, whatever you want to say. The solution is when x is 0, y is 2. X is 0, y is 2. When x is 0, and we check, when x is 0, we take the equation, which is y equals x plus 2. When x is 0, y is 2, 2 equals 2 is okay. And we check the other equation. When x is 0, y is 2, 2 equals square root of 4, 2 equals 2, and that's okay. So the solution is x is 0, and y is 2. Notice it has one solution here. Okay, so I'll keep that in mind. Now I'm going to demonstrate why or how come we have an extraneous root. Let's take the same two equations and solve them algebraically. Notice these two equations are the same as the ones we just had, but when you solve algebraically, you let x plus 2 equal the root of x plus 4. So now we're solving it algebraically. And that means we have an equation. We have to solve this equation which has an x. So what we'll do, we will square both sides. Because we have a root, we square once. So that's x plus 2 squared, and the root of x plus 4 all squared is x plus 4. Now, the reason I haven't squared this one out yet, but I will, but I want to use this equation here to show you why, how we get the two, or how we get the two roots and one is extraneous. Now, let's take this equation and square it. So x plus 2 all squared, we take the x and square it, which is x. We take the 2 and square it, which is 4. We multiply these two to get a 2x, and we double it to get a 4x. We also could write this out twice, x plus 2 times x plus 2, and do a FOIL to come up with this trinomial. Okay, we have this squared, so we get a 4. It's cancelled because they're on each side. So x squared plus 4x minus x equals 0. X squared plus 3x equals 0. X is a common factor, so x squared divided by x is x. 3x divided by x is 3. We get x equals 0, or we get x plus 3 equals 0. And that means that we have x is 0, or we have x equals negative 3. So we have two values of x, so let's plug the values of x in and see which ones work. Because we have two values, we got to find. Let's use x equals 0 and find out what value of y goes with that. So we'll take the equation y equals x plus 2, and we'll sub 0 in for x, so we get y equals 2. So that's 0, 2 as a point. That makes this system true. And we take the other equation, which is y equals the root of x plus 4, and we'll sub 0 in for x. And that, make that a 4. I was working out the answer then before I got the answer. So we sub 0 in, we get y equals the root of 4, y equals 2. And so 0 plugged in this equation gives us a 2 for y. 0 plugged in this equation gives us a 2 for y. So that means the point 0, 2 is okay because it made both equations true. But let's check the negative 3. So let's plug negative 3 into the first equation. And we get y equals negative 1. So that's the point negative 3, negative 1. Okay, now we'll plug or sub that into the second equation. So x is negative 3, y equals square root of negative 3 plus 4, y equals the square root of 1, y equals 1. So that's x is negative 3 and y is 1. So notice this point is not the same as this point. So the negative 3 is not true for both of these equations. So that means the negative 3 can't be used. So it's only x is 0, give me the 2 is the solution to this system. Okay, so notice only one of them worked. But what happens if you take the equation, if you take this line right here and look at that line right here, this one, if we make y equals x squared, or x plus 2 squared, and we take this one and we make it y equals x plus 4. Let's look at the graph. Even though noticed I squared the equation, and we say when you square the equation with a root, you might get, or you could get, an extraneous root. That's because what happens when you square this equation that we had there, and the equation we had to remember was x plus 2 equals the root of x plus 4. When we square this equation, we get a parabola and we get a line. And a parabola and a line could intersect at, remember, 1 point, 2 points, or no points. So let's graph the parabola. So the vertex of this parabola is -2, 0. X is -2, y is 0. So we do a table of values for that parabola. And the table of values, with the table of values, we put the -2 in the middle. So we go higher, which is to the right, -1 and 0. To the left, -3 and 4. So when we put a -1 in this equation, we get a 1 squared, which is 1. So we get the same thing, same number for a -3, we get a 1. And we put a 0 in here, we get 2. 2 squared is 4. So when we put a -4 in here, we get the same number of 4. So that gives us the parabola whose vertex is -2, 0. X is -1, y is 1. X is 0, y is 4. X is -3, right here, y is 1. X is -4, y is 4. And so we have the parabola that passes through these points. And notice the vertex. And notice we got the axis of symmetry. When we move 1 unit left and right, we get a 1. When we move 2 units to the right and left, we get a 4. Now let's graph this line. So we have a line y equals mx plus b is linear. So the slope is 1, as you can see, and the y-intercept is 4. Because the slope is 1, we get a 1 over 1. So we get a y-intercept of 4, which is right here. And we go, slope is 1 over 1, so we go up 1, right 1. We can go up 1, right 1. Or we can go the other way. Down 1, right 1. Down 1, right 1. Down 1, down 1, left 1. Down 1, left 1. Down 1, left 1. Down 1, left 1. So this is the line that's passing through all those points. And notice now the line, which is y equals x plus 4, passes through the parabola at 2 points. So this point is x is 0, y is 4. Sorry, I'm going to put a 2 there. And this point right here is x is -3 and y is 1. So notice when we square, we'll get a parabola and a line, and that parabola and line intersect at 2 points. So I go back to the original equation. I had to bring back the first page in. When we solve this first with just graphing the linear and the square root equation, we only have one solution of 0, 2. Okay, now when we square, we have 2 solutions, but one don't work, and because the line and the parabola intersects at 2 points, so we get an extra value of 0. X is 0 here, and x is -3 here. But remember, the -3 doesn't work because I did the graph of the initial equations. But when we do the algebra, and we come up with what? When we come up with x plus 2 equals the square root of x plus 4. If you were asked to solve this equation, you would do all the work that you're doing here, and you would eliminate the -3 because the -3 don't work. So the only value of x for this equation would be the 0. So squaring the radical in this equation comes up with two roots, and one might be extraneous. You just got to be careful. But in this case, one of them is extraneous. The -3 is extraneous because it won't work, but the 0 will. So that's an explanation why squaring the radical equation, or the equation which has a radical in it, can come up with two roots, and you can have an extraneous root, and that's why. Hopefully that makes sense, and if it does, hopefully you like my explanation and you like my video, and subscribe to my channel if you wish, and click the notification bell, and visit my math website www.mathfullyexplained.com to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye bye.